Hi everybody, it's Mr. Oakes. So we're approaching the end of the year, and basically what we're going to do is we're going to start reviewing slash kind of getting ready for going on to high school. A lot of the stuff that you really go into in high school, you begin learning in 8th grade. So I'm going to start with first a review of some one-step equations. Now I'm starting with that because equations throughout high school actually become very important. They use them in your integrated algebra classes, Algebra 1 and such, integrated algebra 2, geometry, trigonometry. There's always going to be equations being used. So it's good to get back to basics and see, well, how do you solve these problems? So especially when you all of a sudden there's these letters involved and everybody goes, why are letters in my math? Because they represent stuff. So first we're going to talk about, as you see above me, opposite operations, which is key in solving any type of equation. You need to know how to do the opposite operation. So we're going to start with the 4 basics. So what we have here, and I'm going to go actually on the other side, is when we are given a certain operation, what is its opposite? Now, some of these might seem obvious, but I do know that students often forget and run into problems where they just completely forget, well, what's the opposite of a certain type of operation? So, when we are given addition, well, the opposite of addition, if I'm adding something, the opposite is to take away something, which is subtraction. Now obviously, if I'm given addition, the opposite is subtraction. Well, if I'm given subtraction, then the opposite must be addition. These two are related. Addition and subtraction are used to undo each other. So if I have an equation that is using addition, well, in order for me to get something from one side of the equation to the other, or basically get it off of one side so I can continue to get the variable by itself, because that's the goal of solving equations, is to get the variable by itself. So you have something like x equals or y equals, and you can then have, say, oh, well, this is what x equals or y equals. So addition cancels out subtraction, subtraction cancels out addition. Similar thing happens with multiplication and division. Well, when I'm given multiplication, that's when I'm multiplying something. I'm saying, well, I have it this many times. Well, division breaks that up. It says, well, let's take it and break it up. So the opposite of multiplication is division. So then obviously, I would hope, the opposite of division is going to be multiplication. Now, the thing to remember is, if I see that an equation involves addition, I have to undo it with subtraction. If it involves division, I have to undo that with multiplication. Now, I'm starting with one-step equations because one-step equations only deal with one operation at a time. Meaning, if I'm given a problem, then I'm only dealing with one operation. When we get to 2-step or multi-step equations, then I have to go, well, which one am I going to do first? And it's based off of what I'm seeing in the equation. Often we have to then refer to order of operations in order to do that. So, and I may make a video on order of operations, considering how many Facebook posts there are of people going, solve this problem, and people don't know how to do it. So that'll be later on. So first one I have here is x plus 7 equals 12. What operation is going on here? It's addition. So how do I undo that? Well, as we saw, the opposite of addition is subtraction. So what does that mean? What it means is I need to get, because I want to get this x by itself. So as a matter of fact, what I do in class is I put a box around the thing that I want to have by itself eventually. And when I do that, I'm saying that doesn't move. This is on the left-hand side, that's staying on the left-hand side. I'm not going to move that at all, it's staying there. So then I deal with anything that's not boxed up. The only thing that's on the left-hand side with that x that's not boxed up is this plus 7. So I say, well, what is the opposite of plus 7? It's minus 7. Now, an equation is like a balance scale. In order for it to stay balanced, whatever I do to one side, I have to do to the other. So here, if I'm taking 7 off of the left-hand side, then I have to take 7 off of the right-hand side as well, minus 7. So what happens is, this plus 7 minus 7, that cancels out. I cross it out. That's a 0. The only thing now that's left on the left-hand side is x. It's the only thing left there. Alright, and if it helps, you draw a little arrow showing I dropped that down. Then I'm just going to do 12 minus 7. 12 minus 7 is simply 5. And I ask myself, is this in x equals form where I have x on one side and something else on the other? Yes, it is. I'm saying that x equals 5. The last thing I would do here is I would do a check. I'm going to do x plus 7 equals 12, and I put in 5. 5 plus 7 equals 12. 5 plus 7 is 12, so 12 equals 12, and that checks. And that's how you do a check, is you just put it back in and see, do I get the same thing on both sides when I combine things together? I don't stop here. Yes, I know 5 plus 7 equals 12, but I need to get to this point where I have the same thing on both sides in order to know this works. Okay? So here I switched it up a little bit. First off, I switched the order of the number in the variable. So this is 3 plus x instead of x plus 3. But addition is commutable. Alright? I can switch it. Alright? 3 plus 2 is the same as 2 plus 3. There's no difference there except the order. I'm still going to get 5. So that's the first thing I did, as I switched the order there. So we can see that that's okay. The second thing is, now I have a negative here. Okay? So we have to remember, how do we deal with negatives and positive numbers when we're dealing with integers? What do? How do we add them? How do we subtract them? So again, I'm going to look at this, and there's addition. But what most important is I'm looking at this. I'm going and saying, I need the x. I need the x to be a positive x, and I need it now not to move. So I put a box around there. It's not moving. The only thing that's on the outside is that 3, and that's a positive 3. So I'm going to undo that by putting a negative 3, which is subtracting 3. Minus 3. And again, whatever I do to one side, I'm going to do to the other. So I'm going to subtract 3 from the negative 2 as well. That's going to cancel out. And I'm going to bring down the x. I don't need to bring down the plus, because as long as I don't have a negative sign to the left of the x or whatever is there, then my value there is positive for now. Okay, so this is a positive x. Negative 2 minus 3. So I'm starting negative, and then I'm going even more negative. So you could think of it as like I'm digging a hole. I'm starting with a hole that's 2 feet deep, and then I'm digging 3 feet deeper. Well, now I'm increasing the depth of that hole. So I have still going to have a hole that's going to be negative, and then I'm going to have a 2 feet deep plus another 3 feet deep, gives me a negative 5. Okay? I can check this. I'm not going to check every single time, but it's good to see it being done. So I have 3 plus x equals negative 2. 3 plus I'm going to put this in parentheses. Negative 5, because you don't like to have a plus and a negative symbol right next to each other. It just looks weird. That's why we put it in parentheses. Equals negative 2. And when I add these, I'm more negative, so my answer is going to be negative. And then I subtract the 5 and the 3. 5 minus 3 is 2. So I have negative 2 equals negative 2. That checks. So that's a one-step equations that involve addition. Subtraction is not that much different. Okay? I'm always going to start off with, where's my variable? It's right here. I want it by itself. So I'm going to box it up. It's not moving. It's staying on the left-hand side. If it started on the right-hand side, I box it up, it's staying on the right-hand side. If it's on the left-hand side, so it's staying on the left-hand side. I'm not adding anything to it, subtracting. That's not moving in any way, shape, or form. So I have this minus 4 on the same side. Well, what's the opposite of minus? It's add. I'm going to add 4. I need to keep this balanced, so I'm going to do the same thing on the right-hand side. I'm going to add 4. These 4's cancel out. Y comes down. 13 plus 4, 17. Alright, this one I'm not going to check just because I want to keep this going. But notice, I deal with the side that has the variable, and I only deal with that. The 12 didn't move. The negative 2 didn't move. The 13 didn't move. Alright? It's only the things that are on the same side as the variable that get added, subtracted, or move in some way. So we have here y minus 9. What am I going to do? Well, y needs to stay. I got to move this minus 9. That has to go away. It has to go bye-bye. Alright? So the opposite of a minus, that's a plus. Plus 9. I do that on both sides. The 9's cancel out. Alright? I do that. I make sure to cross that out. I don't really need to show the crossing out, but I do that specifically for one of my students this year, Christopher, who was always like, you need to cross out. You need to cross out. He would make sure, I'd be like, what's the next step? He'd say, cross out the, in this case, the minus 9, the plus 9. I'd be like, okay, Chris, that's one of the steps. Alright, so shout out to Chris. Alright, here, I have a negative 5, a plus 9. I'm looking, the first thing, if I have difficulty remembering, well, what am I doing? First I look, are they the same signs? That's a negative, that's a plus, so no. The question becomes, am I going more positive or more negative? So I look, I've got a 5, I've got a 9. 9's bigger than 5, so I'm going more positive. So I'm not going to put anything here because I don't need to when it's a positive. But I'm going to do 9 minus 5. That's 4. And that's how we do one-step equations that involve addition, one-step equations that involve subtraction. So we obviously have 2 more operations, multiplication and division. So we need to show a couple of those. So what I have here, and I have, make that a little bit bigger so you can see it. I have here a multiplication one-step equation. 3x equals negative 45. So, opposite of multiplication is division. Again, I'm going to box up my variable. And the only other thing on that side is the 3. Multiplication, when it comes to these algebraic equations, multiplication is the only one that you don't have to see the symbol for the operation. Addition, I have to see a plus. Subtraction, I have to see a minus. Division, I have to see something that tells me it's division. Okay? But multiplication, I don't need to see a multiplication dot, I'm dealing in algebra, so I'm really not going to see the multiplication x anymore because it gets confusing. Maybe I'll see parentheses, but I really don't have to see those things. So I have this 3 times x. Well, how do I undo 3 times? I divide by 3. So I divide by 3 on the left-hand side. I divide by 3 on the right-hand side. I have to keep the equation balanced. If I have 2 different numbers here, the equation is not going to be balanced. I'm going to get the wrong answer. My 3's cancel out. The x comes down. Negative 45 divided by 3. A negative divided by a positive, negative. 45 divided by 3 is 15. One-step equations, not too difficult. Over here, I have a negative 12x equals negative 96. Notice I'm not using huge numbers, but I'm also not using really small numbers. Again, here's my x. That's the variable that I want to keep. I want to have x equals at the end of this. So, what needs to move? This negative 12. It's not subtraction, because subtraction is I have something minus something else. There's nothing in front of here. So it can't be subtraction. This is a negative number. So I'm dividing by a negative 12. Again, whatever I do to one side of the equation, I have to do to the other. So I'm going to divide by negative 12 on the right-hand side as well. These cancel out. I have the x here. I have a negative divided by a negative. Negative divided by a negative is positive. You can think of it as if I have a negative and I have another negative, I can turn one and I can make a plus symbol. Okay? And I can ward off those vampires that way. So, negative divided by a negative, positive. And so I'm just going to do 96 divided by 12, which is 8. Okay, so that's multiplication. Here, division. You'll notice it looks like a fraction. What you have to remember is fractions are actually division problems. So when I see 4 over 5, 4/5, what it really is saying is 4 divided by 5. And we just leave it in that form. Or we change it to a decimal, if it's appropriate. Here, a divided by 5 equals 8. So to undo that division, I need to multiply. Again, here's my variable. I want to keep it by itself. I want to get it by itself. It's on the left-hand side. I'm not moving that variable. But this 5 has to go. And since it's dividing the a, the opposite is to multiply. So I'm going to write, and I'm going to try not to write on the wall, 5 times on this side, and I'm going to do times 5 on the right-hand side. These two 5's cancel out. I'm left with a. 8 times 5 is 40. I go here. B divided by negative 7 equals negative 7. Now what happens in this case a lot of times with students is they see the same number and they go, oh, well, B must be 1. Because they go, well, nothing changed. It did. Because we want the B by itself. The B is being divided by negative 7. Okay? It's not multiplying negative 7. It's dividing by negative 7. So since it's division, there's got to be multiplication. I have to multiply by what's on the bottom of my division problem. Negative 7. So I'm going to multiply this side by negative 7, and I have to multiply this side by negative 7. These two cancel out. Negative times a negative, positive. 7 times 7. My answer is 49. Not 1, it's 49. Don't believe me? Get a calculator. Do 49 divided by negative 7. What do you get? You get negative 7. So we're going to take a look at these last two. Okay? Now these last two are ones that I just wanted to show so you don't think everything's going to come out nicely and everything's going to look nice. So first one I have here is negative 2x equals 5. Looks relatively simple. Alright, I have here, I have negative 2 times x. My variable is x. I don't want to move it. It's got to stay there. I want x equals, that's going to stay there. What operation's going on? It's multiplication. How do I know? Because the variable is not in front of the negative sign, making that a minus sign. It's next to the number. When I have those two, the number and the variable right next to each other, that's multiplication. So I'm going to divide by negative 2. And when I do that, the other side is 5. 5 doesn't, bless you, 5 doesn't get divided by 2 nicely. It doesn't. You know. Now, depending on what the question asks, you might be best to leave your answer as a fraction. So I might just go here and say x equals, since 5 can't be divided nicely by negative 2, I'm going to have negative 5 over 2. If it said put your answer as a decimal, this I could do. Negative 5 over 2 would be negative 2.5. Okay? But sometimes when you divide, it's not going to come out nice. It might come out as a long string of decimals. Then it'll have to tell you to round to a certain point. And I might make a video about rounding because a lot of students who should know how to round don't know how to round. So look for that. The last one here. 3/4 y equals 6. So there's a couple of things with this one. First off, that's a fraction. So we haven't dealt with that yet in any of these. Oh, what do we do? So this is a special case. We have, in order for us to solve this, we have to use the fractions reciprocal. And what that means is basically, I'm going to take this fraction and I'm going to flip it. The number that's in the numerator, the number that's on the top, is going to wind up in the bottom. The number that's on the bottom, which is the denominator, is going to wind up on the top. And I have to do that to both sides. So what I'm going to do is I'm going to multiply this. I'm going to put the 4 on the top. I'm going to put the 3 on the bottom. Now what does this do? Alright, this means that this 4 can be divided by this 4. This 3 and this 3 can divide each other. And that's going to wind up being 1. That's what a reciprocal does. When you multiply a number by its reciprocal, it becomes 1. They cancel out. But I have to balance this. I have to do it to the other side. So I'm going to go and put 4 over 3 here. And I'm going to do a little thing. I'm going to put a little over 1 here. Because if I have a whole number, I have to remember as a fraction that's over 1. So I can write this 6 as 6 over 1. So these 4's cancel out. Those 3's cancel out. All that's left on the left-hand side is y. If I look here, 2 ways I could do this. I could do 6 times 4, do that, 24, and then divide by 3. Or I can realize that 6 can be divided by 3, and 6 divided by 3 is 2, and now I just do 2 times 4, which gives me 8. Okay? So those are one-step equations. I hope this was helpful to you. I'm going to do something that a couple of you actually told me I should be doing. If you like the video, like it, subscribe to my channel. I'm making videos whether you like it or not, so but it would be nice, more people will be able to see it. Please stay strong, stay healthy, and I'll see you in the next video. Bye bye.